Welcome to True Projects. In this video, we are going to explain about the project, which is an improved framework for detecting thyroid disease using filter-based feature selection and stacking ensemble. So, before getting into the execution, first let's understand what is the project about. We all heard term called thyroid disease, right? It's the most frequent term nowadays. And from let it be the child to the old person, they are being affected with this disease. So thyroid diseases, they affect millions of people worldwide, and they can really disrupt both the physical and the mental health of a person if they are affected with this disease. For instance, conditions like hypothyroidism and hyperthyroidism, they lead to the weight loss, that is weight changes, fatigue, and also the mood swings. And due to iodine deficiencies, I mean, if a person has iodine deficiency, it leads to a major cause of these thyroid disease because they mess with the hormone production. Take thyroid cancer, for example. It is actually the most common type of endocrine cancer, and we are seeing more cases each year. This adds to the overall health concerns globally. But the good news is that if these conditions are diagnosed early and treated properly, most thyroid issues can be managed effectively. This means that people can still lead healthy lives and fulfilling all the needs they want. Even with all the progress that we have made in medical technology, diagnosing thyroid is a major issue. That is, it still relies on lot of manual methods. For example, doctors, they often have to interpret imaging results or analyzing biopsy samples, which can introduce a lot of variability in the results. This makes it tough to catch issues early or get accurate diagnosis right away. On top of that, telling the differences between benign and malignant nodules is really complicated, and accurately diagnosing specific thyroid conditions can be a challenge as well. It is a complex process that leaves room for error, which is concerning when you are dealing with something as important as thyroid health. So here where machine learning comes into the picture. You know machine learning, right? So machine learning is really becoming a game changer for diagnosing different types of diseases. So particularly for diagnosing thyroid disease. It can help to automate the detection process, which could make it more accurate overall. But there are some problems with this also. So it can help to automate the detection process, but there are some bumps in the road. A lot of existing ML models struggle with the issues like overfitting. We know overfitting, right? So it leads to overfitting where they can learn the training data too well but don't perform well on the new cases. And also sometimes they include unnecessary redundant features. So they include unnecessary redundant features that just add noise instead of clarity. Plus, they don't always generalize well. So they don't generalize well across different data sets, which can lead to inconsistent results. That's why we really need a stronger solution. We want to reduce human errors and streamline how we diagnose these conditions, ensuring that we get reliable predictions no matter how common or rare the thyroid issues might be. So this project is all about enhancing how we detect thyroid disease. So in this project, we are using some combination of machine learning models. So here we'll be using some ensemble machine learning models with some smart feature selection techniques. So we will be using feature selection techniques and we'll be using machine learning models. So the idea is to cut down on the noise and get rid of the irrelevant data that might confuse the models. So we have created a new system that uses the filter based feature selection technique for selecting the best features along with the stacked ensemble model. So we'll be using feature-based feature selection technique, filter-based feature selection, and stacking based ensemble model to detect the thyroid disease. What this means is that instead of relying on just one model, we are combining the predictions from multiple models. So in ensemble model, we will be combining the multiple individual models. This way we can boost our overall accuracy while keeping the screening process quicker and cheaper by only using a few important clinical attributes. So by focusing on the most relevant features, we tackle the issues like data imbalance and biases in the models. In short, this approach really shows how effective ensemble strategies can be in the improving accuracy of ML based detection for thyroid diseases. Moving on, as an extension, to further improve the performance of the model, we are using one more advanced ensemble model, that is voting classifier. So in this voting classifier also will be combining multiple individual models. Ensemble itself means that we'll be combining multiple individual models. So in the voting classifier, we will be combining boosting decision tree and extra tree. So this model has achieved highest accuracy than any other model in the project. So we have used this model to deploy it in the front end. And we have developed front end using Flask framework for user testing and user authentication purpose. So by this user friendly approach, the system, this will make it easier for users to test the system, and we will be including user authentication to keep everything secure. This way we can not only improve our model's performance but also make it more accessible for users. Moving on, these are the steps that we have followed to implement the project. So coming to the first step, first we have imported the required packages, and then we have loaded the thyroid data, and then we have explored it to understand the structure and the data in it. After understanding the structure, then we do data pre-processing, we do data cleaning, we drop unwanted columns, then we visualize the data set using correlation matrix, which shows the correlation between the variables, and also the sample outcome, which shows the distribution of the classes in the project, classes in the data. Then we convert numerical categorical variables into numerical using this label encoding technique, and then we append features to the x column, x variable, and target variable to the y variable. And moving on, then we select important features using this mutual info technique. And then we split the data into train and test sets. Training set is used to train the models, and test set is used to evaluate the models. Then we build the models. After building the models, we train it with the data set, that is using the training set. And then we compare them using accuracy, precision, FN score, specificity, sensitivity, AUC score, and balanced accuracy. And we compare them using graphs. And also we have developed front end using Flask framework using SQLite database. So in the front end, users they will be able to give the inputs as a feature values, and that input will be pre-processed at the back end, and that data will be fit with the trained model to make the predictions. Finally, outcome will be displayed to front end whether the person has thyroid disease or not. Moving on, these are the algorithms used in the project. So we have used support vector machine decision tree, KNN, logistic regression, ANN, stacking, ensemble learning, and extension voting classifier. So among all the models evaluated, we found that extension voting classifier has performed well. So we have deployed this model in the front end to detect the thyroid disease. To implement this project, we need basic requirements, which are hardware and software. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front end of Flask, backend framework of Jupyter Notebook, database SQLite 3, front end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand each of them, how will they be used in the project. So coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. So this .py file contains the information related to the front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contain the algorithm information, and this will be loaded into the project code during runtime of the project. And this is the notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is signup.db file. This file is a database file which is used to store the user information. And this is the sample file, so in which we have test cases in it. So these are the test cases using which we'll be doing prediction in the front end. Now let's close this. And in this, we have the data set that is used in the project. So this is the data set that is used in the project to predict the thyroid disease. So these are all the independent features which affect the, are, which will impact the thyroid disease. So based on the features that we give, thyroid disease, it will be predicted whether the person have thyroid or not. Now let's close this. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Now using the command cd followed by the space, paste the copied path and now click on enter. So here if you observe, current directory is changed to the code folder's path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So this is the local host and port, unless configured differently. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project which is displayed in the browser, and this is developed using Flask framework. So here you can see a register link, right? So we need to click on that and register first. So click on register and fill in all the details which are related to registration. After filling in, then you will be signing in. I have already registered, so I'll directly sign in. So click on sign in, give your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? These are the parameters that are supposed to be given to predict the thyroid. So first let's understand these parameters. So the first one which you have is gender. It refers to the biological sex of the patient, which can influence the risk and presentation of the thyroid disorders. Next one is site. It indicates the specific location of thyroid condition within the thyroid gland, such as right lobe, left lobe, or isthmus. The next one is multifocality. It describes whether multiple nodules or lesions are present within the thyroid gland, which can impact diagnosis and treatment. Coming to size, this refers to the dimensions of the thyroid nodule or lesion, typically measured in centimeters, and it can be critical factor in determining malignancy risk. Coming to shape, it describes the physical form of the thyroid nodule, such as oval or irregular, which can provide insights into the nature. Coming to margin, this refers to the edges of the nodule, where well defined margins may suggest benign characteristics, while irregular margins could indicate malignancy. The next one is calcification. This indicates the presence and pattern of calcium deposits within the nodule, which can aid in differentiating between benign and malignant lesions. Coming to blood flow, this refers to the vascularity of the nodule assessed through Doppler ultrasound, where increased blood flow may be associated with the malignant nodules. Coming to composition, this describes the makeup of nodule, whether it is solid, cystic, or mix of both, influencing diagnostic considerations. The last one is multilateral. This indicates the thyroid condition is present in both the lobes of thyroid gland, which can affect the overall assessment and management. So this is all about the parameters. Let's give the inputs to all these parameters. For that, we have to open the sample file in which we have test cases. So let's open that. So open the sample file. These are the test cases. So let's try with the first test case where the gender is 0. It means person is female. Site is also 0. Multifocality value is 1. Size is 1. Shape is 1. Margin is 1. Calcification is 1. Blood flow is 1. Composition value would be 2. And multilateral is 0. Now click on predict. So the given input, it will be pre-processed at the backend and then it will be fed to the extension model, and that extension model is giving us a prediction through the application that is malignant, which means that the patient is suffering from thyroid disease. Let's give the other set of inputs. So click on prediction. Let's try using the sixth test case. So the gender is 1, which means the person is male. Site is 2. Multifocality value is 0. Size is 1. Shape is 0. Margin is 0. Calcification is 1. Blood flow is 0. Next composition. So coming to composition, composition is 2 and multilateral is 1. Click on predict. Here we got the prediction that it is predicting benign, which means that Patient has no thyroid disease. Now let's try with the other test case. Click on prediction. Let's try with this test case where the gender is 1, which means person is male. Site is 0. Multifocality is also 0. Size is 1.5. Shape is 1. Margin is 0. Calcification is 0. Blood flow is 1. Composition would be 2. And multilateral is 1. Now click on predict. So here we got the prediction that malignant, which means patient is suffering with the thyroid disease. Let us check with the one more last test case. So let's try with this 16th test case where gender is 0, site is 1, multifocality is 0, size is 1.3, shape is 0, margin is 1, calcification is 1, blood flow is 1, composition is 2, and multilateral is 0. Now click on predict. So here we got the prediction that patient has the thyroid disease and it is malignant type. So this is how we need to give the inputs to all the parameters. Based on the given inputs, then we will be getting the prediction whether the person has thyroid disease or not. Let's check with the graph. So click on graph. So the first one we have is sample outcome graph, where on x-axis we have the classes and on y-axis we have the count of that particular class. Moving on, this is the correlation matrix, which shows the correlation between the two variables. And here we have the accuracy comparison graph, through which we have evaluated all the algorithms. So here on x-axis, we have the accuracy score, and on y-axis, we have the algorithm names. If you observe, extension model voting classifier is having the highest accuracy. And here we have the precision graph, recall graph, FN score graph, sensitivity, AUC, and balanced accuracy. Among all the graphs, among all the evaluation metrics that we have used, extension model is having the highest accuracy score. Now click on logout. In this way, by using the ensemble models and the selected features from the data, we will be able to predict the thyroid disease accurately, and this will help the doctors, patients to diagnose the disease early. That is to diagnose their thyroid disease early. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.